This is week 1 videos, and we continue now with the topic combining like terms. Now, what we're referring to as like terms are these pieces in an expression that are monomials being added or subtracted. So in this expression, 4x cubed plus 2x cubed, each of these is a monomial, and these are like terms because if we look at the variable x, it's the same variable here as here. They're both x's, and they're both to the same power. Anytime we have exactly the same letters or variables, and each of those letters is to exactly the same power, we can put those two things together. In this first example, think about 4x to the third power as a 1x cubed plus another one plus another one plus another one. 4 of these x cubes added together, 4x cubed. And 2x cubed is 2 of these x cubes added together. Well, if you expand it like this, you can clearly see why it's 1, 2, 3, 4, 5, 6 of these x cubes. But obviously, every time we go to combine our like terms, we're not going to expand them like this. That takes way too much work. We're just going to look at the coefficients, the numbers that the variables are being multiplied by, and just add up these coefficients. So 4 plus 2 of this variable x to the third power. So we get from this to this in one short step, and don't usually write out what's in between. This is just for understanding purposes. Let's look at the next example. We have 5 ABs, 5 times A times B, subtract 2 ABs. Of course, you could expand it. Here's your 5AB, 5 of them. And here's the 2 ABs, 2 of them. And I'm taking 2 of them away from 5 of them. Let's see, take away 2 of them. That would leave me 3 AB. But of course, we're always going to take the shortcut, and when we see it's exactly the same variables to the same powers, a to the first power and b to the first power, a to the first power and b to the first power, and I can just add or subtract the coefficients. In this case, 5 minus 2 is 3ab. Alright, we're going to do a couple more complicated examples with a little bit more going on. We'll go down to the adding and subtracting polynomials. We'll do these 2 examples, and then we'll do an extra practice video. So let's head on to adding and subtracting polynomials, because in this process we're going to be adding like terms. If you're given a long expression, chances are there's a way to make it shorter so that if somebody comes along and tells you what the variable stands for, what number to put in for the variable, you can do it much more quickly if this has been condensed, if it's been shrunk down. So let's find out how to do that. If we look at this first parentheses, there's nothing in front of it. So there's really no reason to group these 3 terms, because I can't add or subtract them because they're not alike. It's not the same, it's the same x, but this one's to the third power and this one's to the first power, and then the 8 has no x on it at all. So these are not like terms. Here in this pair of parentheses, these are not like terms either, because plain x, x squared, and no x at all, none of these can be added together. So we can literally just take off these parentheses and rearrange the terms and add the ones together that are alike. So let's do that. I'm going to rewrite this, and let's see, we've got 3x cubed, and it might help if you change the subtraction to plus a negative. So I'm going to do plus a negative 1x. Remember, there's always an invisible 1 in front of any bare naked variable. Plus a negative 8, that's the same as subtract 8, plus a negative, plus 5x, plus x squared, and plus a negative 5. So now I'm going to look at this and I'm going to look for any like terms. So let's look at 3x cubed. Are there any other terms that have an x cubed in them? Nope, 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 nope. So this one I'm just going to rewrite all by itself. It can't be combined with anybody else. Alright, now let's look for any plain x's, x to the first power. Well, I've got one here, and I'm going to circle a coefficient with it. And I've got another one here, and I'm going to circle that plus sign in front of it. So remember that I'm going to be working with a positive 5. And I don't see any other terms that just have an x in them. So now I'm going to combine these two. I'm going to add them together. Negative 1 plus 5 gives us 4x. It's positive, so because all these terms are being added or subtracted, I'm going to write plus 4x. Now I'm going to grab another color. Let's look at this negative 8 next. It's a plain number, and I also have another plain number here. So these two can be combined. And negative 8 plus negative 5, negative 8 and negative 5 added together is negative 13. So I could either write plus negative 13 or, just to save time, write minus 13. It means the same thing. And finally, I have just one variable left. I took care of the 3x cubed. I have x squared left. And there's no one to combine him with, so it's just plus x squared. Alright, so there we go, adding monomials together by combining like terms. And this is as short as we can go. I can't combine any of these other terms because none of them are alike. Let's go to the next one. When we're subtracting polynomials, we have to be careful. This polynomial subtract this one. What we have to be careful about is this minus sign right here. Back here, everybody in this parentheses was going to get added. So nothing to worry about when we take the parentheses off. But here with a subtraction sign, that means everybody in here needs to get subtracted. It's like I'm distributing subtraction to each of the terms inside. So if I want to take off the parentheses so I can combine my like terms, I need to look in front of the parentheses and watch what I do. I'm going to check this one too. There's nothing in front of it, so this one I can just take off. 3x cubed minus x minus 8. Just take it off and write exactly what's inside. But watch what happens when I take this one off. The 5x wants to get subtracted. The x squared, which is being added here, needs to get subtracted. Now, well, here we're subtracting subtraction, or subtracting a negative. So notice how 5x became minus 5x, plus x squared became minus x squared. These two became opposites. Well, this is now going to have to become opposite because it's like we're subtracting a negative. So this will become plus 5. So warning, this is a very common mistake. If you have a minus sign in front of a set of parentheses, all the terms inside either change their opposite or the operation in front of the term changes to the opposite operation. Okay, now let's combine our like terms. Let's see, 3x cubed. Are there any other x cubes? Nope. You just write that one down. There's nothing to combine it with. Alright, bare naked 1, or excuse me, a bare naked x, I can put a 1 there. Let's see, any other plain x's? Yep, there's 1 here and 1 here. Now watch what I do when I circle these terms. Since I didn't take the time to write plus on negative 1x, what I'm going to do is I'm going to circle that operation sign in front of it. And when I combine it with this one, I'm going to think of this as negative 1x plus negative 5x. Same thing I did up here. I'm just being lazy, and I'm not going to write plus a negative. So negative 1 and negative 5x's adds up to negative 6x's. So I write minus 6, and don't forget the x. Okay, next I have a plain number. And it says subtract 8. I'm going to think of that as negative 8 when I combine it with this plain number, positive 5. So notice again how I'm circling the operation symbol in front of the number. So negative 8 and positive 5 make negative 3. So I'm going to write minus 3. Okay, I took care of that guy. Just one left. Minus x squared has no one to combine with, and this is our final answer. If you'd like a little more practice on this, tune into the next video and I'll give you some more examples that will help you with your homework and your first quiz.